Jai Hind to all. My name is Divya Sharma. Now today's video lecture is on gradient divergence of a vector and divergence theorem. Now first, gradient of a scalar field. The gradient of a scalar field V is a vector that represents the magnitude and direction of the maximum space rate of increase of V. Now this is in 3D x, y, z axis. Now here let us consider point P1. This is point P2. This is field, and this is the line, open line from P1 to P2, and this is take some part of this line that is represented as dl and make an angle theta on this line, and G is represented as gradient of a scalar field. Now this is a field represents V1, then V2, then V3, like this. Now dV is equal to del V upon del x dx plus del V upon del y dy plus del V upon del z dz. Now here you can see this is the gradient and this is dl. So gradient is represented as del V upon del x unit vector of x plus del V upon del y unit vector of y plus del V upon del z unit vector of z. Now here consider this is your dv is equal to g dot dl. This is your g gradient, this is dl. As you already know, in Cartesian coordinate this is represented as dl. Now g dot dl. Now here g cos theta dl. Now if you will differentiate dv upon dl, then you will get here g cos theta. Now dv upon dl is a maximum when theta is equal to 0 degree. Now when dl is in the range, that is means you can calculate dv upon dl maximum when your theta is 0 and dv upon dl that is equal to g. Now here dv upon dl is a normal derivative, thus g has a magnitude and direction as maximum rate of change of v. Now g is the gradient of v. Now here this is the representation of gradient v, del v. Now here del v upon del x unit vector of x plus del v upon del y unit vector of y and del v upon del z unit vector of z. This is in form of Cartesian coordinate. Now gradient of a scalar field. Now we have to study in Cartesian coordinate, cylindrical coordinate and spherical coordinate. Now gradient v is represented as this del v is equal to del v upon del x unit vector of x, del v upon del y unit vector of y, del v upon del z unit vector of z. This is in Cartesian coordinate. Now here in cylindrical coordinate, del v is equal to, now in cylindrical coordinate you all know what are the coordinates, rho, phi and z. Here in Cartesian x, y, z. But in spherical this is represented as in coordinate r, theta, phi. So you have to find out gradient of a scalar field in these coordinates, right? So in cylindrical coordinate del v is equal to del v upon del rho unit vector of rho plus 1 upon rho del v upon del phi unit vector of phi plus del v upon del z unit vector of z. Similarly you can write down for spherical coordinates. Del v is equal to, gradient v is equal to del v upon del r unit vector of r plus 1 upon r del v upon del theta unit vector of theta plus 1 upon r sin theta del v upon del phi unit vector of phi. So these are the gradient of a scalar field in Cartesian coordinate, cylindrical coordinate and spherical coordinate. Now divergence of a vector. Divergence of a field at a given point P is the outward flux per unit volume as the volume shrinks about P. Means shrinks about P means you should know P is your source or sink. Now divergence A is equal to, it is represented as del dot A is equal to limit del V tends to 0. Now integration, this is your closed surface and A dot ds upon dv del V. So this is the representation of divergence of a vector. Now here we can study here P, source, sink or what, right? So divergence of A at a given point P is the outward flux per unit volume as volume shrinks about P. Now here you can see your P is here, this is your source and all fields are going outward from this point P. If P is source, so positive divergence. Now here you can see all fields are coming inward. So P is your sink. Source means your start point and sink means your end point. So all fields are reaching at this point P. So here negative divergence. Now your field is in upward direction and your P point is in between this field. Now here zero divergence. Now divergence of a vector. What is A dot ds? So you have to find out this. So vector field A at closed surface S. Now this is in 3D x, y, z. You are now here you are considering Cartesian coordinate. Now here this is your closed volume. Here you can see top side. This is the front side. So if it is front side, so here also back side. This is top side, so bottom side. This is right side, so consider left side. And your P is your P. You are considering here this point P. Now A dot ds, so closed line surface you have to find out. So front, back means integration of front side, back side, left side, right side, top side, bottom side into A dot ds. Now here V represents volume enclosed by surface S. Let us consider this is a cylinder of volume V and closed surface is represented as S. Now for Cartesian coordinate, it is represented as del dot A, delta dot A, del Ax upon del x plus Ay upon del y plus Az upon del z. So this is in form of Cartesian coordinate. Now for cylindrical coordinate, here also you have to represent it in form of rho, phi, z, and for spherical, it should be in form of r, theta, phi. So represent all these in cylindrical coordinates like this. Del dot A, delta dot A or gradient dot A is equal to 1 upon rho, del upon del rho, rho unit vector of A, rho, plus 1 upon rho, del upon del phi, this A phi, now plus del upon del z, Az. You can see here Ax, Ay, Az. So here represent A, rho, A phi, Az. Okay. And for spherical coordinates, gradient dot A means del dot A is equal to 1 upon r square, del upon del r square ar, plus 1 upon r sin theta, del upon del theta, a theta sin theta, plus 1 upon r sin theta, del upon del phi, a phi. So this is the representation in Cartesian coordinate, cylindrical coordinate and spherical coordinate. Now properties of divergence of a vector field. So what are the properties? Following are the properties we have to study. First, it produces a scalar field because scalar product is involved in the equation of divergence or divergence, right? Now divergence of a scalar V, that is represented as div, V makes no sense. Now here del dot A plus B. So you can use here distributive property like del dot A plus del dot B. So this is your LHS, this is your RHS, so it should be equal to this one. Now here del dot VA is equal to V del dot A plus A dot del V. So these are the properties of divergence of vector field. Now let us take an example. Here we have to find out divergence of these vectors. So first is P is equal to x square yz unit vector of x plus xz unit vector of z. So here ay is missing, right? So that is equal to 0. Now here q is equal to rho sin phi unit vector of phi plus rho square z unit vector of phi. Now z cos phi unit vector of z. So all three coordinates are present. Now here for the third one, w is equal to 1 upon r square cos theta unit vector of r sin theta cos phi unit vector of theta cos theta unit vector of phi. So here also all three coordinates are present. Now we have to find out divergence of all these vectors one by one. Now first, now use divergence for Cartesian coordinate. As you all know, here coordinates are x, y, z. So find out del dot, or you can say delta dot p, that is equal to del px upon del x plus del py upon del y plus del pz upon del z. Now here put the values of x, because y is absent here. You can see here unit vector x and z are present, right? So y is absent here, so write down here 0. Now for the x coordinate, write down here x square yz and differentiate it with respect to x. So you will get here 2xyz. Now here you will get 0. Here when you are differentiating xz with respect to z, you will get here x. So this is the answer for the first one. Now second, here you should know the formula of divergence in cylindrical coordinate. So this is the formula: 1 upon rho del upon del phi rho unit vector of rho plus 1 upon rho del upon del phi unit vector of phi plus del upon del z unit vector of z. So you should know the formula, then only you can put all these values. Now you can see in the question that all three coordinates are present. So you can put the values here: 1 upon rho del upon del rho. So this is for unit vector of rho, this is unit vector of phi, and this is the part of unit vector of z. So you can differentiate it with respect to phi rho. Here you can differentiate this with respect to phi, and here we can differentiate it with respect to z. So here when we will differentiate it, you will get here 2 sin phi. Here when you are differentiating with respect to phi, so no term of phi is here, so that is equal to 0. Now differentiate it with respect to z, so you will get here cos phi. So this is your answer for the second one. Now the third one, you have to find out divergence for spherical coordinate. So you should know the formula for spherical coordinate, mean divergence for spherical coordinate, that is equal to delta dot w 1 upon r square del upon del r square, this is your part of unit vector of r, plus 1 upon r sin theta del upon del theta, this is the part of unit vector of theta, 1 upon r sin theta del upon del phi, so this is the part of unit vector of phi. So we can differentiate it with respect to r here, here we can differentiate it with respect to theta, here we can differentiate it with respect to phi. So here you will get this result while we are differentiating r by r, then after the theta, then phi, then you will get these three terms here, and this is the final result, that is 2 cos theta cos phi. Now divergence theorem. So it states that total outward flux of a vector field A at a closed surface S is the same as the volume integral of divergence of A. So that is equal to this one. Now you should know this formula: A dot ds closed interval of surface, that is equal to delta dot A dv. This is your for closed surface, this is for volume. So this is your LHS, this is your RHS, it should be equal to this one, then only you can apply for this. Now this is the proof. Let us consider subdivide volume V into a large number of small cells. If the Ki cell has a volume delta Vk and is bounded by surface Sk. So let us consider this is a cylinder. Here volume V is represented as and closed surface is represented as S. Now this is the formula for this: A dot ds, this is the left side. Now here we can integrate, close integrated with respect to Sk. Now here this is your summation K, means you can put the values for Ki cells and has volume delta Vk. is bounded by surface Sk. So you can represent it in by this formula. And final result is same, A dot ds closed surface integral, that is equal to delta dot A dv. So this is equal to this for divergence theorem. Now divergence theorem is used to calculate closed surface integral of a vector field. So you should know this point. Now closed surface should be such that it encloses a volume, that is hollow volume. Okay, and already we have covered A dot ds, that is equal to integration delta dot A dv. This is dv is scalar. So this is for Gauss divergence theorem. Now here this is your LHS part and this is your RHS part, and Gauss divergence theorem is not a universal theorem. We can apply it by if A is continuous and differentiable at each point in V enclosed by S, then only LHS is equal to RHS. If A vector tends to infinity at any point in V enclosed by S, then above theorem fails there. Okay. So first we can calculate it, that this is your LHS, closed integration A dot ds. So this is your LHS and you have to prove it. This is for the Gauss divergence theorem, or you can find out it by using this formula, then this one, then this one. Let us consider you are considering the case of cylindrical and your top and bottom are closed. So how you can find out? This is for, let it be, this is for top, this is for bottom, and this is for curved surface. So first we can find out it, this should be equal to this one plus this one plus this one, means well while you are considering for the case of top, bottom and curved surface. Now if your vector is continuous and differentiable, then it should, you can find it by using this formula, and all both are same when your this condition verify, then only you can say LHS is equal to RHS. Now let us consider a question that A vector is equal to 10 e की power minus 2z in bracket rho, unit vector of rho plus unit vector of z. Now determine the flux of A out of entire surface of cylinder, rho is equal to 1 and z varies from 0 to 1. Now here it is given, consider closed bottom, top and bottom. If it is not given, then you have to consider it, let it be your top and bottom, it should be closed. Now here from this question, rho is equal to 1, z is equal to 0 to 1, closed surface and closing volume, and phi is equal to 0 to 2 pi. Now first we can calculate it for bottom, sorry top and first top, then bottom, then curved surface. So this is your figure. So draw a cylinder, here rho is equal to 1, here is also same. So this is for, here you can draw x, y, z, rho is equal to 1 here, so it should be same, rho is equal to 1. Now here z is equal to 0, here z is equal to 1, and you can see in the question it is given here. Now for upward, your direction for Az means unit vector for z, it is positive, here for the bottom it is negative. And if you are considering for the case of rho, in outward direction it is positive, and if in you are considering inward direction, then that is equal, then that is negative. Now first method, apply first method, then that is equal to A dot ds closed integration, now top, bottom and curved surface. First we can calculate by using this method. First you should know, if you are considering the case of cylindrical, you should know dl is equal to d rho, unit vector of rho, plus rho d phi, unit vector of phi, dz, unit vector of z. So you should know dl, then only you can find out ds, this ds, right. So first we can calculate it for A dot ds for top, and for top z is equal to 1, as you can see in the figure, z is equal to 1 here for top and z is equal to 0 for bottom. Now if you know dl is equal to this one, so you can find out, here you can see for top z is varies from 0 to 1, means it is changing. So z is only changing, rho and others are other parameters are same. So if z is changing, so take here z, direction of z here, and other parameters you can note down it. If you are considering this case, this is your unit vector, so you can write down it like this: d for ds, d rho, rho d phi. So write down here rho d rho and d phi. So this is your ds and unit vector z. So here you know a this is given in question, a vector that is equal to 10 e की power minus 2z. Here you have to write down, this is your formula, right? A dot ds. Okay, this is the formula. Now put the value of a dot ds. So ds already you have calculated by using this dl, rho d phi. So put here this value, and you all know this is given a vector. Now you can integrate it and you will get here this answer. Now here you know the limit, this is your lower limit, this is your higher limit. So for rho your limit is varies from 0 to 1 and phi 0 to 2 pi, as already we have given in question that rho is equal to 0, means it varies from, if you are considering the limit case, so 0 to 1, z is equal to 0 to 1, phi is equal to 0 to 2 pi. So put all these limits here and you will get the result. Now this is the case for top. Now after that you have to find out for bottom. So you all know left hand side a dot ds, this is for bottom. Now for bottom z is equal to 0. Now here z is equal to 0 because you can see in the figure your bottom side z is equal to 0 and top side your z is equal to 1. Already we have done for the top side. Okay. Now ds is equal to rho d phi. Only the difference is there is a negative direction of z. Now put all these values. This is your a vector dot ds. So ds you can calculate it, as already we have done in the previous question. How we can calculate? If you want to consider unit vector z, then you can draw it, ds is equal to d rho d phi. Okay. So already we have done for ds. So put the value of ds here. This is your a vector. Now you can put the values for rho 0 to 1, phi 0 to 2 pi. So you can easily calculate it, integrate it, and you will get this result minus 10 pi. Now for the curved surface. Now curved surface, your formula is same, a dot ds. Okay. Now rho is changing. For curved surface your rho is changing from 0 to 1. If it is changing, so you can take unit vector for rho, and if you are considering rho, so you can take like this, this is rho. Now you have ds is equal to what? Rho d phi and dz. Okay. So write down here rho d phi dz. So this is your ds, and a, this is given in the question 10 rho e की power minus 2z. This is your ds, already we have done. Now you can integrate it by using this ds and a and ds. Now for limit z, your limit, lower limit is 0 and upper limit is 1, so you can integrate it easily. Now and for phi your limit is varies from 0 to 2 pi, so easily you can integrate it and you will get the result, that is equal to 10 pi in bracket 1 minus e की power minus 2. So this is for the curve. Now we have done for top, bottom and curve. Now if you want to calculate LHS, that is equal to top plus bottom plus curve. So you can note down it, you can calculate it, flux 1 plus flux 2 plus flux 3, that is equal to 0. You can check here, this is 10 pi e की power minus 2 minus 10 pi and 10 pi minus 10 pi e की power minus 2. So you can add all these three, then you will get result here 0. Now for check for the divergence theorem. Now you all know what is the formula for divergence theorem. This is a dot ds closed integration equal to integration delta dot a vector field dv. So this is the formula for Gauss divergence theorem. Now you can find out by using this. First you have to check that your A, this one you have to check it, it should be continuous and differentiable. If it is continuous and differentiable, you can do it by using Gauss divergence theorem. Now here from the question you all know this is given 10 e to the power minus 2z in bracket rho, a rho, unit vector of rho, unit vector of z, and rho is equal to 1, it is given, z is equal to 0 to 1, z varies from 0 to 1 and phi varies from 0 to pi. So put all these values in this formula and you can find out. Now first you should know del dot A for cylindrical coordinates. So you should learn this one, 1 upon rho del rho in bracket rho, a rho plus 1 upon rho del upon del phi, a phi plus del upon del z, a z. So you should know this formula, then only you can put the values. So its value is absent in the question. So write down here value for a rho and a z. So a rho and a z, this is a rho 1 upon rho del rho. So you can integrate it by using rho with respect to rho, and this is equal to 0, and this one you can integrate with respect to z. So you will get here by using these differentiation, you can differentiate it and you will get this result, that is equal to delta dot a, that is equal to 0. So put this value 0 here in this formula. If you are putting here 0, then that is equal to 0. So you can see by using first method as second method, your both right hand side it should be equal to 0. Now note down, net outward flux though closed surface can be 0 even if individual fluxes from open surfaces are non-zero, as we have done in the question. So in above question divergence theorem is also applicable. Why it is applicable? Because your A vector is continuous and differentiable. So you can verify it, your LHS is equal to RHS. Thank you.